Good morning. I'm going to continue my video lecture series. I'm going to continue my previous video, right? In that video, I'll explain 0, 1, 2, and then continuous right 3 will be explained by here. Right 3. This techniques used stripping and dedicate one drive to store parity. We're having n number of block, but one block contains the parity information. That is on right 3. Embedded ECC information is due to detect error. If they having any error in the block 1, it will be detected in the ECC informations. Data recovery is accomplished by calculating the exclusive information record on the other drives, because an input output operation addresses all the drive at the same time. Write 3 cannot overlap input output for this reason. If you're having a block diagram here, if the write 3 parity on separate disk, see here, if you're having a disk 1, 2, 3, 4, if block A having a parity in separate disk block, if you're having a parity A disk 1 block A1, A2, AB1, B2. Okay, if you're having a parity here, for A parity 1 to 3, A parity 4 to 6, B parity 1 to 3, B parity 4 to 6. Okay, separate disk having a parity, that is an write 3. And then write 4 is this level use large strips, which means a user can read record from any single drive. Overlapped input output can then be used for read operation, because all write operations are required to update the parity. No input output overlap is possible. Okay, this is an write 4. Same as block separate blocks. For every block A, if you are having one parity, for every block B, the parity for B, then every block of C having a C parity, if every block of D having a D parity. That is write 4. Then write 5 is this level is based on parity block level stripping. This is an block level stripping. Parity information is stripped across each drive, enabling the array to the functions. If any one drive were failed, the architect enables read and write operation to span multiple drives. This result in performance better than that of a single drive, but not as high as write 0 array and write 5 requires at least 3 disks. If it often at least 5 disks are for performance reason, generally considered a poor choice for use on write intention system, because of the performance impact associated with write parity data. When a disk fails, it can take a long time to rebuild a write 5 array. If you're having a write 5 here, if you're having a block, in each block they're having a parity. If you're having block A, the block A parity will be in that block. If you're having in block B, the parity will be having the block B. And then block C contains means the C will be happened here. The C parity will be displaced. With the parities 4 D, the parity D block will be contained the in each block the parity will be appear in that respective block, that is on write 5. Then write 6 is this technique is similar to write 5, but it includes second parity schemes distributed across the drive in an array. The use of additional parity enables the array to continue functioning. Even if two disks fail simultaneously, the extra protection comes at a cost. Write 6 array often have slower write performance than write 5. In this also they are having an disk but not an parity and not an ECC code for the separate block. In this, the every block and every disk having an ECC code and parity. In disk 0, the contains A, B, C, D block also with that parity block and ECC correct code detection block also taken place in the single disk. That is an write 5. This is an advanced level of write 6. This is all when compared to all the 6 levels, the level 6 is an advanced level, because they are having a, if the error will be detected in block 1, it have to go with the parity of block and then correct the error. That is an disadvantage. In this all the process, the 6th level is rectify the problem In one block they having an error parity and error code detection 2, that is an error detection code with parity, that is an write 6. This is an advanced level of write process. Okay, thank you.